Hello everyone, let's start with sample skewness. So sample skewness is given by G1 is equal to n upon n minus 1 into n minus 2 into summation I goes from 1 to n xi minus x bar, that is the average, divided by s, the whole cube. Okay, so n is the sample size, n is the size of the sample, and xi are all the data points. Okay, xi is the ith data point, x bar is the sample mean, and s is the sample standard deviation. It's the standard deviation of the sample. Let's take a smaller example. Let's say we want to test something for all the students studying in our institute, and let's say n is equal to 1000. So what we'll do is we'll just see a concept over here. We have n upon n minus 1 into n minus 2. Okay. Now what I'm saying is, what I'm claiming is that when n is large, when n is large, then n is approximately equal to n minus 1 is approximately equal to n minus 2. Okay. So therefore, this quantity can be approximated as n into n multiplied by n. Let's take the case when n is a small number. Okay. In this case, n upon n minus 1 into n minus 2, if you calculate this, it will come out to be 0.42. And n upon n into n will be zero point 0.2. So these are significantly different. Okay. But let's say I take a larger value of n, let's say 1000. There are 1000 students. Okay. And in that case, if I calculate the same thing, n upon n minus 1, n minus 1 into n minus 2. Okay. So if we calculate this, this will come out to be 0.001, and I'm showing, increasing the precision just to prove the point. So this is the exact value up to 6 digits of precision, 6 places of precision. And the same thing I calculate using n upon n multiplied by n, then this will be 1 upon 1000, which is 0.01. So I can say that this is a good approximation for this when n is large. Okay, that is in case of a population. Okay, so coming back to our formula. Okay, so if this is my sample skewness, okay, so this is my sample skewness. Now in this, if I say that n is large, okay, and when I'm going for the population, what modifications will I do to this formula? Just as we saw over here right now. Okay, so I can modify this formula as, okay, for population skewness, I can say that, you know skewness is equal to n upon n into n, that is 1 upon n, summation I goes from 1 to n. Now here n are the total number of data points in the population. Okay, and xi, instead of x bar for population we'll write mu, and instead of s for population we write sigma and q. Okay, so these are the formulae for skewness. In the next video, we'll take a look at an example, a solved example on sample skewness. Thanks for watching.